Hi everybody, this is Miss McClellan here to go over notes IM2 3.2.4 with you. We have two learning goals. Our first one, I will be able to define what I have been doing with slope ratios and angles as the tangent function. And two, I will be able to use a calculator to perform the tangent function to solve for missing legs of right triangles when one leg and the slope are both given. Let's get right to it. Problem 3-99. Will it topple? The Leaning Tower of Pisa is expected to collapse once its angle of slant is less than 83 degrees. Currently, the top of the seventh story, which is right here in our diagram, point A, is 50 meters above the ground. Also, when weight is dropped from point A, it lands 5 meters from the base of the tower, as shown in the diagram. So we have this triangle. I'm going to draw it again, just because for me, sometimes that can be easier. We have 50 meters by 5 meters. And we're going to use our trig table graphic organizer, which I have but not on screen, to determine the angle at which the Leaning Tower of Pisa slants. So using my trig table graphic organizer, I'm going to first identify the slope. So we have a slope of 50 over 5, which is 10. And then on my graphic organizer, I find the slope 10 and this angle that corresponds to that slope is 84. So we have an 84-degree angle. And now we have to use this to answer an applied question. Is the Leaning Tower of Pisa in danger of collapse? Well, I don't know. Let me look back above. It's expected to collapse when the angle of slant is less than 83. 84 is not less than 83, so it is not in danger of collapsing. I know because 84 is not less than 83. Three 100. Solve for the variables in the triangles below. It may be helpful to first orient the triangle by rotating our paper or by tracing. Okay, let me think. So we have this triangle. I'm going to redraw it. If this is 79, I can solve for theta. Theta plus 79 plus 90 equals 180. So theta equals 180 minus 169, which is 11. So this is an 11-degree angle. And I have W and 12. So when the angle is 11 degrees, the slope is 1/5. Therefore, W over 12 equals 1 over 5. I cross multiply. I have 5W equals 12. I divide both sides by 5. And I have W equals 2.4. Part B. Here we have a 22-degree angle, and you know what? I kind of don't feel like solving for theta this time, so I'm not going to. I'm just going to redraw this in a way that feels more familiar. Let's see. 22 degrees. The angle across from 22 is Z. And the side across from 22 degrees is Z, and the side to the right, the side touching 22 degrees is 8. My angle is 22 degrees, so using my graphic organizer, I find that my slope is 2/5. So I have 2 over 5 equals Z over 8. I cross multiply. I have 16 equals 5Z. I divide both sides by 5. And I get that Z equals, did I make a mistake? 3.2? I did not make a mistake. Okay, very good. Next problem. Okay, I'm going to draw this again in a way that feels more familiar. My angle is 18 degrees. The side across from it is X. The side touching it is 15. I know from my graphic organizer that 18 degrees gives me a slope equal to 1/3. So I have X over 15 equals 1/3. I cross multiply. I have 3x equals 15. I divide both sides by 3. And I have x equals 5. Okay, we continue. 3-101 multiple methods. Tiana, Maylin, Eddie, and Amy are looking at the triangle at right to try to determine the missing side lengths. Tiana declares, hey, we can rotate the triangle so that 18 degrees looks like a slope angle, and then change of y is 4. So they did what I've been doing. They drew the triangle, 18 degrees right here, 4 and A. And then they said that 18-degree angle tells you that the slope is 1/3. So they did 4 over A equals 1 over 3, cross multiply, 12 equals A. Let's see what Maylin did. Maylin says, I see it differently. I can tell that change in y is 4 without turning the triangle. How can she tell? Well, I can see, I see. Tiana rotated it, but Maylin could tell without rotating. I think it's just because 4 is diagonally opposite across. We say opposite. From the 18 degrees. Change in y is always across from the angle. Um, Instead of across, we usually say opposite. And Eddie says, what if we use 72 as our slope angle, then change an x is 4? What's Eddie saying? Ooh, okay, that's interesting. So here, that doesn't look like a right triangle. I'll do it again. I wonder if I have a right triangle. I do not. Okay, anyway. So Eddie is using 72. Where would we get the angle 72 from? I think it's from this. I think it's because 18 plus 90 plus 72 equals 180. So if we consider this as 72, let's see, if this is 72, then A is now across, so A is here, and 4 is here. So if we change our reference angle, if we change our reference angle, then change in X and change in Y switch. You know what? We need more detail to its complement. Then X and Y switch. I'm pretty sure that's still confusing. Look, 72 plus 18 equals 90 tells you that if the slope for 72 is A over 4, then the slope of 18 is 4 over A. It switches. One of those two angles add to 90, and that's because it's just like reorienting a triangle. Complement is when two angles add to 90. Okay. It turns out, wonderful students, that we can get tangent from a calculator. Hold on. So we're actually going to do our math notes before we do that last problem, 3-103. We're going to do a little bit of practice even before we do that problem. Okay, so for math notes, first of all, for any slope in a slope triangle, the ratio that compares change in y with change in x, we've been calling that the slope ratio, but formally we actually should be calling it the tangent ratio. So we've been calling this the slope ratio. For us, this has been the slope ratio. And we have, what we say is we tan of a slope angle. We read this as tan of a slope angle equals change in y over change in x. Now for any angle, the tangent ratio is constant. Meaning no matter how big you make your triangle, that ratio, that fraction, that slope is always the same. And that's regardless of the scale of the triangle. And whether the right triangle is oriented as a slope triangle which is here, or not. Maybe it's reflected, maybe it's rotated. You can still identify change in y. That's always going to be the leg that is opposite the angle. And by opposite, we mean across from. And change in x is always going to be the leg closest. We say adjacent to the angle. So we have tan of theta is opposite over adjacent. Let's do some practice. So right here, I'm going to draw a couple of practice problems. I'm on page 2 of our notes, and we're just adding some handwritten practice. First of all, if the angle is 45, then the slope is 1. We're going to make our calculator tell that. To make our calculator tell us this, with your calculator, you're going to first make sure your calculator is in a mode called degree. I pressed mode and then I'm selecting degree and I'm pressing enter. And then quit that page so that you're back in the beginning. Anytime you press tan, you're asking for the slope ratio for a specific angle. So I'm going to do tan of 45 and it equals 1. With our calculator, we press tan and then 45 and then enter, and we get 1. So here are a couple of questions. What is the slope ratio for A, 21 degrees, B, 42 degrees, C, 16.5 degrees? Well, we can use the tan function on your calculator to get all of those. 21 degrees, no problem. Tan, 21, enter. And we usually use 4 digits. So this is 0.383, and I'm going to round up to 9. The slope is 0.3839. If we were to draw a slope triangle, we would have 0.3839 as the rise and 1 as the run. That's 21 degrees. Formally, we would write tan of 21 equals 0.3839. For 42 degrees, no problem. Our calculator can do that. Tan of 42 is 0.9004. The slope is 0.9004. If we were to draw a slope triangle, we would have a rise of 0.9004, a run of 1 for a 42 degree angle. We write tan of 42 equals 0.9004. And for 16.5, no problem, your calculator can do that. Tan of 16.5 is 0.2962. Tan of 16.5 is 0.2962. Okay, with that practice, we're going to go back to problem. What number is it? 3-103. Okay, here we go. Now, this problem had a little bit of a typo in it, and I don't totally know why, but we can fix it. This should have been write an equation such as tan of 14 over 1 equals x over 5. If you could go ahead and fix that, I'd appreciate it. So we've got this triangle. And we're going to say, we're going to solve for x. So I see that my angle is 38. That means I'm going to do tan of 38. And that's 0.7812. So this is going to be similar to a triangle. Ooh, let me erase that. I'll draw it as a slope triangle just to be consistent with what we've been doing previously. So we've got a 38-degree angle, and the slope is 0.7812, rounding 7813, 0.7813 over 1. Okay. So we could write 0.7813 over 1 and set that equal to the corresponding parts. So 0.7813 corresponds to x, because x is across from the 38-degree angle, and then it's over 8. And to solve for x, we cross multiply. And I don't think we'll have to divide because it's just by 1. So we have 8 times 0.7813 equals x, which gives us that x is 6.250. I'm always using 4 digits because that's traditionally what you do for tangent. Okay, another problem. Again, I'll draw my slope triangle. I'm doing a 73-degree angle, and I want to know the slope. So to get the slope, I say tan of 73, and that's 3.2709. I'm rounding. 3.2709. The run is always 1. And I'll set that up as a proportion. So I have 3.2709 over 1 is equal to, the side opposite of 73 is 9, and 9 is over x. I cross multiply. I have 3.2709x equals 9. And then I'm not done because x is not alone. So I divide both sides by 3.2709. Oops, didn't mean to take up so much space, but here we are. And I have x is 2.752. And I should say approximately. It's not an exact answer because I rounded. Okay, next problem. Oh, it's a 45-degree angle. Anyway, I know that the slope for 45 degrees is 1. So 1 equals x over 14. X is 14. 45 degrees is a really precious special angle. Okay, my guess is that you need a little bit more practice. So I hope this is all we have for the notes, but I hope that you take the time to watch the video and do some of the practice 3.2.4. It's worthwhile. Okay. Thanks, everybody. Hope you have a great day.